if an individual is exposed to high levels of radiation, and let me give you some quantitative hallmarks. So no human being survived higher than 3.5 gray of radiation dose. The cause of death is due to the loss of stem cells either in the hemopoietic system, which is the bone marrow basically making blood, and the gastrointestinal system, which is essential for absorption of nutrients and also protecting us from the microbes that live in our gut that help digest the food and produce important vitamins. The acute radiation syndrome is a deadly disease that develops either within the first 10 days after high dose radiation exposure, usually 10 gray and above. And our drug discovery program is now using 16 gray in animal models of the acute radiation injury, and we get very good survival. So that's just to make the point that although you can lose your gut and die within 10 days, we have been able to generate a radiation countermeasure that can protect all kinds of animals from the deadly consequences of this radiation injury. Our lead product is called Rx100. Basically, over the years, what we have come to understand that the natural compound that we modeled in our drug discovery is a natural protective agent that has evolved in our bodies to protect cells from genotoxic stress. And that can come in various flavors. For example, ionizing radiation is one of these DNA damaging agents, or chemotherapeutics, or oxyradicals that are generated as a byproduct of inflammation. So those attack our DNA and cause mutations that can be deadly. And that leads to a self-destruct program called apoptosis, programmed cell death in cells. This natural compound, in response to DNA damaging interventions that can come from the environment or from cosmic rays, is there to protect our genome. Radiation damages your DNA. If your cells are unable to repair that DNA damage within a very short period of time, the cell will self-destruct. What our drug does is gives the cell a little extra time to repair its DNA, boosts its DNA repair with a very high fidelity, so actually the cell can correct the damage and have a good chance of surviving. And this is particularly important in the gut, because if you do not help this gastrointestinal stem cell that drives the renewal of the gut over a 3-day period, after 3 days you have no gut left. And what we have learned that our drug can actually spare these gastrointestinal gut stem cells, and they are able to regenerate after a little pause, and we are talking about a few hours, and then regrow a new gut lining that protects the individual's absorptive system and also from bacterial invasion. So that's really what we have done.